problem. This is a story problem. I know that's not always people's favorites, but you can handle it. All right, a boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. So say here's, I'm going to draw a little picture because I like to. So say here's New Orleans, or New Orleans, or however you want to say it, and it travels upstream for 4 hours. Okay, so upstream for 4 hours. The return trip only takes 2.8 hours. And I don't know where they went. It'd be interesting to know where they stopped. Okay, the return trip only takes 2.8 hours because the boat travels 3 miles per hour faster. And that makes sense, right? Up current, down current. All right, 3 miles per hour faster downstream due to the current. Okay, how far does the boat travel upstream? Okay, so we've got this information, and the thing that we need to know for this problem is that distance equals rate times time. Okay, that is just a classic formula. I'm sure you've used it before. And the thing we need to remember too here is that the one thing that is constant for both going up and coming back is the distance. So what we're going to do is we're going to take the trip going up equal to the trip coming down as far as the rates are concerned. Okay, so what we've got here is we've got rate times time. So my rate, or my time is 4 hours. I don't know what my rate is, but my time is 4 hours. And that would equal my distance, okay? And then on the way back, my rate is 3 miles per hour faster, okay? And it only takes 2.8 hours. So I've got 2.8 hours times my rate plus 3 miles per hour faster. And that also equals my distance, okay? And since my distances equal each other, I know this is kind of complicated, but stay with me, okay? Since my distances equal each other, right, going up and coming back are the same, I can set these two equal to each other. So I have 4r equals 2.8 times my rate plus 3 miles per hour. All right, so I need to solve this. So 4r equals 2.8r, I distribute this, and then 2.8 times 3 is 8.4. Okay, I'm going to subtract 2.8 from both sides because I need to get the r's on one side. And I get 1.2r equals 8.4. And when I divide through by 1.2, I get my rate is 7, okay? So my rate is 7 miles per hour, but that's not what the question is asking or what the problem's asking. It says, how far does the boat travel upstream? Well, if I'm going 7 miles per hour and I'm gone for 4 hours, then my distance is my rate times my time, which is 4 hours, and that gives me 28 miles. So that is how far upstream they went. Maybe someday I'll get on there and see how much 28 miles is north of New Orleans, but anyway. Okay, last slide is just your homework. And the thing that I need to explain here, and I think that this is confusing to people, because they're like, well, when am I going to use my book? Your book is only in case you can't get onto Big Ideas. Big Ideas Math is your book. It's your book, it's the questions from the book. So when I give you questions right here, this means that when you go to Big Ideas Math, these are the questions that you're going to get from the book. Okay, so I hope that's not too confusing. I also put this picture up. I thought it was interesting. This is where the Mississippi River starts. It's in Minnesota, and so we live fairly close to this. This is Lake Itasca, and this is where Mississippi River starts, and you can actually walk across right there. So if you ever go up there, you can say, I walked across the Mississippi River. People will be like, what? That's crazy. But that's where you can walk across. So let me know if you have any questions.